Problems with maintenance cause everyone stress. It can be hard to get out of this breakdown, reactive repair cycle. Why is it so hard though? And why is maintenance even important? To demonstrate the importance of maintenance, we're going to take a look at two of the most common challenges that I see teams facing in maintenance. I'll explain why this is important, and then through a case study, I'm going to show an example of how you could possibly use these steps to improve your own maintenance and reliability for yourselves. The steps to maintenance can actually seem really overwhelming and complicated, but it actually doesn't need to be. It's hard to find straightforward, simple information to know what to do first and what to do next. There's not a lot of resources for maintenance either. If you compare that to disciplines like mechanical or electrical engineering, there's a lot of background and books and text for those. It's often not even a topic that's covered in universities. Two of the most common challenges that I see teams facing in maintenance is number one, getting management support or operations support to make the changes that you've recommended, or even give you time to do the maintenance that you're asking for. And two, knowing what to do first or what to do next. How do we even get started in the first place? So firstly, let's look at why this is also important. Maintenance problems can be broken down into three categories: safety, environmental, and cost. Safety and environmental are pretty obvious. Someone gets hurt or the environment gets harmed. Costs can be a little bit more complicated. Maintenance consequences, we can break these down into two different types: direct costs and indirect costs. For example, for direct costs, things like labor, so staff or contractors, as well as overtime. You can include parts also once they're in regular use, and replacement parts, the ones that sit in your stores for a long time. Also overheads like your building costs, your utilities like your gas and electricity. Then there's the indirect costs, the breakdowns. Breakdowns cause operation losses. They cause downtime, production losses. You might miss deliveries to customers, so there might be penalties for that as well. We have to hold extra spares sometimes. If we think that we get lots of breakdowns, we need more in our spares and our stock. That costs money. Emergency purchases. Sometimes you might have to spend more money to rush out and buy things short notice or close by that may be more expensive. You have to pay more for that. Then there's all of the time spent managing crisis, all of your troubleshooting and running around and things when you could be better off doing other things. Every time we shut down, we have to set up again. We have to start up again, and that can even cause more problems as we go as well. What about the repair costs themselves? Parts and labor are the obvious ones, but there's also the consequential damages to other equipment or back to safety and environment as well. It all adds up. So back to our initial challenges then. Why is this important? How do we get management to support our decisions? And how do we get started in the first place? What do we do first? So here's an example of a plant that I worked in a while back. We had constant breakdowns. Every type of failure you can imagine, we had it. And it was always at the worst times, the unexpected times. Friday afternoons, driving home from work, you get called back in. Saturday mornings, drop your plans, you drive back in. Safety and environmental problems were obvious ones. They were the ones we have to emergency react to. But there was a lot of breakdowns and a lot of damages and potential incidents. Root cause analysis, the list just got bigger and bigger and bigger because the teams didn't have time to meet to come and fix those things properly rather than those temporary repairs they were also familiar with. So the existing plan, it was a plan, but it clearly wasn't working. So the solution that they thought at the time was, like many other businesses, let's do more maintenance. Let's do it more frequently. Let's do more tasks, because surely more maintenance means better performance. Well, you probably hopefully realize at this point now that it doesn't. The plan is let's take a step back first. Let's look at why things fail. Use the data, use the information that you've got, use the experience of your team, use the knowledge of the team to select the right tasks for the right failure types. Perhaps we don't even have a task at all. Perhaps we don't need a task if the consequence isn't big enough, if we don't care enough about the consequence. So this is what we did. We undertook a program called Preventative Maintenance Optimization. Prepared all of the existing data, all of the existing tasks, ones on walls, ones in systems, and we break them down into tasks. We then sat in a room for a week, and that included technicians, electrical and mechanical, supervisors, engineers, a facilitator. We went through every single assembly or component and we asked, what is it meant to do? How could it not do that? Do we even care if it doesn't do that? What can we do about it if we do care? So this is what we call the PMO, Preventive Maintenance Optimization. It's a little bit related to the reliability-centered logic, but not as in-depth. After creating new tasks, deleting old tasks, modifying existing tasks, they are all then documented with the reasons for doing them or not doing them in case we need to modify it later or we need to look back. We're going to put a comparison of labor time before the program was changed versus after. We're going to do the same for cost before and after. We want a comparison to see what influence or improvements our program is making. We then document that in a report, present it to the management to get buy-in from the management team and the operations team. This is where we are now. This is the plan to get there, and these are the benefits to do it. So hopefully now you're seeing the answer to challenge 1. How do we get support? We demonstrate that we use a best practice process. We document it, and we present the relevant information to get understanding, commitment, and buy-in to the new process. Number 2, where did we start? We select an area that is of high priority, something we care about, something is critical. Perhaps that's cost, perhaps that's frequency of breakdowns, maybe it's potential of safety or environmental harm. We fix the fundamentals first, carry out a review of the existing program and break down the tasks to relevant tasks, the basics. Use the data and information that you've got, and if you don't have it, you better start getting it soon. Select the right tasks that match the right types of failures, and only if the consequence is something we care about. Document the changes, put a performance of before versus after to demonstrate the improvements. Keep it simple. Hopefully this has given you a couple of ideas of how you can improve maintenance in your own process, how you can get management support, and maybe some of the steps that you need to take to do that. Because if our teams understand why maintenance is important in the first place, we might just have a chance of getting our maintenance program underway and actually improving what we think it's going to improve. Thanks for listening. I'll see you next time, and good luck on your own maintenance journey. Bye for now.